This video is for topic 6.1, Endothermic and Exothermic Processes. The objective for this topic is to explain the relationship between experimental observations and energy changes associated with a chemical or a physical transformation. So when we talk about changes in energy, we divide our universe into two parts. We divide it into the system and the surroundings. The surroundings are anything not included in the system. You get to define what the system is, or it's defined for you if you're working on a question. So when we talk about energy going in and out, we're talking about energy going in and out of our system. So it's transferring between the system and the surroundings. So just like we have the law of conservation of mass, we have the law of conservation of energy as well. So the total energy is the system and the surroundings. We're looking at how it's moving in and out of our system. We can equate a change in temperature to a change in energy. So we use temperature as a way to measure the energy. And we're looking at the average kinetic energy. So a high temperature is going to have a high average kinetic energy, and a lower temperature is going to have a lower average kinetic energy. You have to keep in mind that kinetic energy is related to speed and mass by the equation 1/2 mv squared. So it's not a direct relationship between temperature and speed, because speed is also going to speed and mass are also going to affect energy. We can, however, relate directly temperature to the average kinetic energy. We also need to be aware that our change in energy is the heat or the enthalpy plus the work done by the system. That's not something we're going to get into in a huge amount of detail in this class, but energy is a combination of heat and work. An endothermic process is any process where the heat is going to be transferred from the surroundings into the system. So energy is entering the system. So when we're looking at heat, that's Q. So Q is going to be positive. If we're looking at work, work is also going to be positive. So the surroundings are going to be doing work on the system. So that's an endothermic process, is anything where energy is entering the system. A positive Q and a positive W get you a positive change in energy. So that would be an endothermic process. An exothermic process would be the opposite. So that's where heat is going to be transferred from the system to the surroundings. So energy is exiting the system. So you're going to have a negative Q because your heat is leaving your system. Work is done by the system to the surroundings in an exothermic process. So you end up with a negative work as well. So a negative Q and a negative W gets you a negative overall change in energy. So a negative change in energy is going to be an exothermic process. We make the assumption that no work is being done when we are looking at energy. So that means if our work equals 0, our heat is directly related to our change in energy. So that's to simplify some things. This is not a rule that always exists. But for the purposes of this class, we're going to assume that work is 0, that no work is being done. Therefore, our change in heat or our change in Q is related to is the same as our change in energy. When we think about how things dissolve, energy plays a role. And so we have to think about the strength of the intermolecular or the interparticle interactions, or our IMFs, before and after. That's going to determine when something dissolves, if it's going to be an endothermic or an exothermic process. So you have to break ionic bonds in an ionic compound, and you have to break the intermolecular attractions between water, and then you have to form intermolecular attractions between the ions and the water. So when you think about the solvation process and the strength of those interactions, stronger interactions are going to require or involve more energy. Things that involve more energy are going to ultimately have a greater change in energy during that solvation process. So you'll want to think back to your intermolecular forces and Coulomb's law, thinking about what makes those strengths, what determines those strengths. So things that have strong interactions are going to be small and highly charged particles. So that's a brief overview of endothermic and exothermic processes and how it relates to our changes in energy.